Hello again, you sick, twisted weather freaks. Welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. This is a special Thursday night edition of This Week in Weather dealing with Hurricane Florence and then probably Helene and Isaac after this. So let's get right to it. I'm your host, meteorologist DT from Weather Risk. I'm also known as the Colonel of Confusion, the Captain of Catastrophe, the Commander of Chaos. Let's talk weather. Remember, here in Weather Risk, I kind of specialize in thinking outside of the box. I think that's very important, as opposed to what everybody else is thinking. I don't do a lot of consensus forecasting. Sometimes, of course, the consensus is correct, but a lot of times it's not. So, and we've seen some of that with the early predictions that Florence was going to go out to sea. All right, this here is the 10 o'clock or 5 o'clock advisory, I should say. And of course, we have the 8 p.m. Intermediate advisories up here. So, obviously, this here is Florence, and this here is remains of Gordon. But also we can see this system here, which is likely to become Helene, I think, and then this one is Isaac. And again, you notice that they have very high percentages of development over the next few days. So, and this one is likely to stay on a more westerly course. So this one, don't know yet. So, but we'll get into that all in just a second. All right, let's take a look what else is going on. This here is a widescreen satellite picture from this afternoon, midday, and you can see Helene is looking pretty, Florence is looking pretty sick. We'll get into that. This here is the other system, which is likely to become um, Helene, and this here, the Isaac. This is a big looking system here. This one's got potential as well, and it's pretty far south off the coast of Africa. So there's been some speculation that this one's going to go out to sea. I kind of have doubts about that. All right, this is the afternoon satellite picture, and you can see, actually, this is midday, and you can see that again, Florence was looking pretty sick. And now you can see the circulation of the system if you look at these light clouds coming in here, but this is all sheer, and as a result, the thunderstorms, instead of being wrapped around the center, are all pushed to one side. You see that they're pushed to one side here. This is the other system, Helene, and this, again, big view of what's going to be Isaac. All right. Just briefly, I want to show you the potential for this next system already. The ensembles, the GFS and the European ensemble show a high probability of this system developing and staying, as you can see, really far to the south, possibly moving into the Caribbean islands or the Caribbean Sea here. So I just wanted to point that out to you. All right. Now we'll take a look at Florence during the day, and you can see I used this image earlier when I did the audio, but you can see there was a closed eye this morning. And even though all the thunderstorms should be wrapped around the center, which is what we saw yesterday, when Florence was a monster storm, we had perfect symmetry. But here you can see that all the storms are on one side and is experiencing southwest wind shear, blowing all the storms from over to this side. And you can see at midday the eyes are actually even gone, and then after the evening satellite picture, it's looking even weaker, with now you can just see this one big burst right around the center. Now, this is not a complete surprise. In fact, the model data was showing that. Now, this is the morning setup here for early on this Thursday morning, and we can see where Florence is and then the other weak system behind it. So this is just like a reference point to where things are this morning at midday. Now, here, this was the European model for September 2nd, which I believe is Sunday. Now, this is for 120 hours. This is for tonight and tomorrow morning. And notice that the European model did correctly forecast Florence would weaken significantly. And of course, this is Helene, and this is Isaac. As you can see, the European model already has this as a tropical storm. And again, given what we saw coming off the coast of Africa, coming off the coast of Africa, this is probably going to be a tropical storm very quickly. But the point is that the European model did see the weakening, so it's not a surprise. This is our depiction, a widespread screen of the Atlantic Basin, and we can see this dust here is in between the systems. So the Florence is now north of the big dust cloud off Africa. This here is going to be Helene. It's south of it, and this is the bigger system right here off the coast of Africa. So there we go. So the dust is not a problem. Now let's take a look at the shear. Now remember, this here, it represents our shear tendency. So these high values here represent strong winds at certain levels of the atmosphere. Here, this is showing the shear, it'll last 24 hours. Now, basically the white lines here show you that the shear is increasing, and here the shear is decreasing. So this is Florence. Now you see the yellow and the orange here. If you look at the scale, that's 40 to 50 knot winds, which is why the storm is being ripped apart. Now, remember we said this is decreasing the blue stuff. See this down here, the blue stuff, okay? Look what's up here. See all this? Decreasing shear. So once Florence gets past this, it's going to take off again. There's nothing ahead of it in terms of the shear in the southwest Atlantic Ocean. Indeed, if we take a look at the tendencies, and again, this is a streamlined map, and we can see where the shear is here again. So this takes us out into the future. We can see down the road for the next 2 or 3 days. This here is our Florence, and again, notice the orange color here, showing why the strong winds. See the strong winds right in this area, 25, 30 knots. Okay, and even higher. But look at this, all this in here. See this light blue and green stuff? Look what that is down here. Let me change marker so you can see it. I change color here. All right, so you can see it. This is all very light stuff in here. So the point is that as we go, Florence gets out of the current shear, it's going to end up doing a much better job of surviving and re-intensifying. This was the 11 a.m. advisory. You can see the westward shift. Remember just a few days ago how the Hurricane Center and everybody on TV was telling you this? I guess that's not true anymore, is it? No. And then we have the 5 o'clock advisory, and again you can see it saying way south in Bermuda, headed for the southeast U.S. coast. And if we look at the shear down the road as well, we can see this is 48 hours and 84 hours out. The shear, the scale here, just to give you an idea, this is the strong stuff in here, but we have this very light blue stuff, which is, ordinary wind shear, and then nothing in the southwest Atlanta. Look how calm it is here. Look how calm it is here. So things are going to become favorable. And again, the two southern systems coming off Africa, not much in here, not much shear in here. You can see very, very light colors in here. So again, we're going to have a very active here couple of weeks coming up. Sea surface temperatures, southwest Atlantic, very warm, much above normal. The Bahamas are cold, and portions of the Atlantic Ocean are not particularly warm. This whole area, as you can see, is pretty chilly. But in here, once it gets into this and turns this way, it's going to have pretty warm water temperatures. Indeed, let's look at the actual numbers. Again, now in case you don't know this, for hurricanes to really intensify, you want to have water temperature of at least 28 degrees centigrade or better, and even 30 is even better. So as Florence gets into here, you can see all these warm water temperatures, 28, 29, 30 degrees centigrade. So yes, it's really going to take off as it approaches the south, goes into the southwest Atlantic and moves towards the U.S. southeast coast. And the models show that. We can see the thing intensifying by 120 hours, 108 hours, that's day 4, day 5. Look at the scale here so you can see it. Category 3, Category 4, Category 2, very good, really high probabilities of that. Now, this I showed for you from early this morning. This is the European model from early Thursday morning. So let's go over this carefully. The red line here shows a trough in the jet stream. That is to say, the jet stream, instead of doing this, does this. So this is the trough right in here. You see it? That's what it's called. It's called the trough. This red line represents the trough. Earlier, it was believed that this trough was going to take Florence and kick it out to sea. But as you can see, the European model correctly shows a strong ridge, the Atlantic high, sitting between the trough and Florence. So this trough cannot kick it out to sea. And as a result, Florence heads for the U.S. coast. And then you can see Helene here, and we can see Helene here as well. But because of this enormous ridge, this trough can't kick it out. Now, the GFS model, having inferior initialization, inferior physics, overdoes the trough and weakens the ridge. And we'll get into that in a second. So this is from early this morning. This is a display of all the different models. Now, the models which are not run on the GFS grid, that is to say all the hurricane models are run off the GFS plus the GFS model. But the British model, which is the yellow line, the Navy model, and the European model, They're not run off the GFS grid, and they all have a U.S. landfall. It is the U.S. GFS model and the GFS ensembles and the hurricane models which show a sharper turn off the coast from early this morning. Okay, now this is the afternoon run, and we can see the same sort of thing. Again, the hurricane models not run on the GFS grid, the American model grid, all show a much further west track and possible U.S. landfall. The GFS model, the GFS ensembles, the hurricane models all show a close miss or staying out off the coast. This is the American model from early Thursday morning. Notice where the landfall is. This is a significant Category 3, maybe a Category 4 hurricane right there, Wilmington, or maybe Morehead City on early Thursday morning, September 13th. And then it goes over Norfolk. You see that just west of Norfolk, between there and Richmond. And then it goes turns east and goes over Salisbury, Maryland, out to sea. You can see it here. And what does this look like? This is from early this morning. This was the Thursday morning run, and you can see the high winds here. See, the core of the hurricane that made landfall, according to this model, makes landfall here, Morehead City. This is Norfolk and Hampton Roads right here, and over here is Richmond. So there's the low here. It's a Category 2 hurricane. You see this light brown stuff? That's winds around here. And again, these are knots. This is 60, 80, 85 knots. That's winds gusting up maybe to 90 or 100 miles an hour. If this scenario is correct, Richmond would see winds up to 50, 60 miles an hour. If this scenario is correct. And then, like I said, it goes over the Delmarva. You'll see that in just 1 second. And then it goes out to sea. So the morning GFS from Thursday morning, this is the Thursday morning run, okay, from the European model, has it going this. Right? Okay. Now, that's a pretty bad track for the coastal areas. If you're in Charlottesville and you're in Roanoke, if you're in Leesburg, it's not so bad. If you're in Raleigh, it's not bad. Winston-Salem, Greensboro, you're okay. It's rainy, it's windy, it's not a big deal. But the coastal areas would be a problem. Now, one of the reasons why the European model is doing this is because the European model has a very strong Bermuda high right off the coast, which forces the hurricane inland. This is what we saw with Isabel in 2003. The ridge is very strong here, and it forces the hurricane to go inland. And we can see this with more clarity on the afternoon European model. Now, this is the Thursday afternoon European model. Okay, good. Let's take a look-see. Thursday afternoon, all right? And we can see this, see the light line here? See this line? This is the Bermuda High, the Western Atlantic Ridge. This is why the Bermuda High is so important in figuring out hurricane tracks for the East Coast. Now, of course, this is Florence right here. You can see it as Florence. Now, you see this little dipsy doodle right here? This is a little trough. Boop, 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 right there. Now, you see it's over Texas, over Oklahoma, but it's not anywhere close to the East Coast. And as a result, the European model has this very strong Atlantic ridge, and it pushes Florence into the coast. Let's take a look-see. There it is. And we can see clearly on Wednesday and on Thursday and where the European model takes it into the North Carolina, Virginia coast. This is the Bermuda High. See how strong it is? And you see how strong it is here? There it is. And that little trough is now gone. The European model says, don't worry about it. This enormous high, this Bermuda High, which has given us days and days and days of heat in late August and September, is so strong, it's going to force the hurricane inland. That's what the European model is saying. And of course, we look at the track. This is the afternoon run. It's a little further to the coast. It's not inland. It's still a very big hit for Hatteras and Morehead City, Elizabeth City, Hampton Roads, Lower Virginia Eastern Shore, Salisbury, Ocean City, Maryland. Very big hit. And of course, the European ensemble shows a significant shift. The one on the left was the European ensemble from this morning. And like I posted earlier, you can see many of the lines, see the little dots here, take it off the coast. But now you can see all these lines are concentrated and are favoring this. This is a much more solid indication that this is going to get very close to the coast, if not make landfall. Now let's talk about the wretchedly bad GFS model. This here is the 18Z GFS. So you can see it. 18Z GFS. This is the American weather model. There it is, the hurricane, 943 millibars, strong Category 4 hurricane. Okay, so this here is Hatteras. In case you don't know your landmarks, this here is Boston and Cape Cod. So there it is on Monday night, early Tuesday morning. Now, look what it does. Here it comes here. Okay, that's fine. This is Tuesday night, getting close to the coast. Now it turns due north. Wednesday night, it's well off the coast of Hatteras, 300, 400, 500 miles off the coast. It's a Category 4 hurricane in the Gulf Stream, but it's not a threat. It's a lot of big waves, a lot of ocean current, but not a big threat in terms of rain or wind or damage or tidal flooding, or storm surge, I should say. It just, just don't see that. And then it does this. And like I said, this is 150 hours. This is Wednesday night. It's off the coast. The problem is, this is what the GFS did from early this morning, and this is what the GFS is doing this afternoon. It's consistently taken the hurricane close to the coast, but off the coast. Now, why is it doing it? This is why. Pay attention. This is going to be really cool. Okay. There is a little disturbance here. Let me move this so you can see it, like I pointed out earlier. See this little dipsy doodle right here? This is a little trough. Now notice where the trough is. It's over the Mississippi. It's over the Mississippi River, Louisiana, Arkansas. See it here? And because it's closer to the hurricane, it weakens the Atlantic ridge, so the hurricane stays off the coast. So you can see that. Let me clear it so you can see. See where the ridge is here? Now let's go back and take a look at the European model. You can see it here. See the difference? This to that. There you go. So that's the main difference. That's what's going on here. Now look at the GFS ensemble. This is for Tuesday morning. It's a lot of stuff. There's a strong agreement that through Tuesday morning, everybody's in agreement. European, GFS, Canadian, British model. We all know where Florence is going to be. It's going to be right here. Now this is Helene and this is Isaac. So like I said, it's going to get busy here, boys and girls. There's no doubt about that. Now look what happens. You zoom in here. Oops, let me clear this out. And then you can see, there it is, 120 hours out. And look now, here's the spread for Thursday night. The GFS says, I have no idea. I've got some of it here. I've got some of it at Virginia Beach. I've got some of it 300 miles south of Halifax, Nova Scotia. GFS has no clue. So, and why it doesn't have no clue? Because it's a piece of crap. That's why. Okay, now other possible solutions. Now, you see a lot of people on social media, weather weenies, people want to hype this storm, tell you we're all going to be a catastrophe, blah, blah, blah. The 1933 Chesapeake Bay hurricane. Now, that has some similarity to it. I can't deny that it's a possibility. Notice it also turned to the north and the northeast off the coast. So it does have that general hook. But there are other possibilities as well. The reason why the 1933 hurricane is getting all the play is because it's the biggest disaster. So, again, let's breathe a little bit. This is Isabel. Isabel's also was like the 1933 hurricane. It came in a little differently over Hatteras or in Morehead City, but it was a big hit for Richmond and for Norfolk, for Eastern Virginia, Maryland, D.C. Experienced some flooding from that. So that's a possibility as well. But also, in case you may remember, Hurricane Emily, 1993, in September, hit Hatteras, then bounced off the coast or went out to sea. And then look what it did. It stalled for a couple of days off the coast, which is what the European model is indicating. Okay, that's a possibility. Here's another one for you. This is Hurricane Felix, 1995. Look what it did. Stalled off of Hatteras and the Virginia coast for 3 days. Never actually made landfall. And then this is Helene, 1958. Bounced all along the coast, went out to sea. So there's several different possibilities here. So all of them are close hits, close misses. So that's what you have to look out for. So in summary, the westward shift in all the models continues. Every one of the GFS has the same flaw. It's overdoing the trough in the Midwest over the Louisiana Delta. And because it does so, it weakens the Bermuda High, and this allows the GFS model to turn to Florence out to sea. I think that solution is bullshit, but maybe the GFS model will be right here. Okay, models which are not run on the GFS or the GFS grid, like the Navy model, the British model, the European model, all show some sort of U.S. landfall or a coastal swipe where it just slams along the coast for a few hundred miles, then goes out to sea. Then after Florence is gone, we're not done yet, Helene and Isaac. So there are a lot of possible outcomes. By Sunday, Monday morning, Weather Risk and others will probably know a lot more. And that'll be the time to, whether or not the time to take action or not. Anyway, hope you enjoyed the video. This is meteorologist DT from Weather Risk. I'll talk to you soon on the Facebook page and on the Twitter page.